Hello everyone, today we will solve some more problems which are based on Lagrangian equations. The third problem is, consider the motion of a particle of mass m moving in a plane. Using the plane polar coordinates r, theta as generalized coordinates, find expressions for the components of generalized force. What are radial and tangential components of the force? Now, as you know that for the plane motion, we can correlate Cartesian coordinates with the polar coordinates, such as x is equal to r cos theta and y is equal to r sin theta. Here you can see that particle of mass m is placed in this xy plane. Its Cartesian coordinates are x and y, and polar coordinates are r and theta. So if we differentiate equation 1, then we can find x dot, and similarly if we differentiate equation number 2 with respect to time, then we can find y dot. So your x dot will be like this and y dot will be like this, and these are, let us say, equation 3 and 4. Now the kinetic energy of the system is, for the Cartesian coordinates, you know that it will be 1 by 2 m x dot square plus y dot square. If you put the value of x dot and y dot, then the kinetic energy in terms of the polar coordinates becomes T is equal to 1 by 2 m r dot square plus r square theta dot square. Let us say it is equation number 6. Here it is given in the problem that the generalized coordinates are r and theta. So our Lagrangian equations will be in terms of the r and theta. Here we have to find the generalized force and also the force components. So for the generalized force, you know that when we derived the Lagrangian equations from the D'Alembert principle, you know that your general value for the generalized force Gk was equal to d over dt del T over del Qk dot minus del T over del Qk. Right. Similarly here for the radial part, it will be gr is equal to d over dt del T over del r dot minus del T over del r, and for the theta coordinate it will be d over dt del T over del theta dot minus del T over del theta is equal to g theta. Let us say it is equation number 7 and it is equation number 8. Now from equation number 6 we will find the value of the del T over del r dot and del T over del r. So del T over del r dot, it will be equal to 1 by 2 m, and the differentiation of r dot square, it will be twice r dot, so it will give you del T over del r dot is equal to mr dot. Similarly del T over del r is equal to mr theta dot square. Let us say these are equation 9. Now from equation number 6 we can find del T over del theta dot, and it will be equal to mr square theta dot, and similarly del T over del theta, it will be equal to 0 because there is no term for theta, so it will be 0. And let us say it is equation number 10. Now we will find the equation of motions. So your gr will be mr double dot minus mr theta dot square, and g theta will be d over dt mr square theta dot minus 0, and let us say it is equation number 12. Now you know that for the radial and tangential forces, we have written that your Gk was equal to F dot del r over del qk. Similarly, here for gr we can write f dot del r over del r. Here you know that earlier that your r you can write as r cos theta I plus r sin theta j. Here I and j are the unit vectors, right? So when we find del r over del r, it comes out to be unit vector r. We have earlier derived it in our earlier video, right? So when we put the value of del r over del r is equal to unit vector r, then your relation gr becomes f dot unit vector r. So when you find its value in terms of the magnitude, then it will be equal to fr. R is it is for radial part, because the modulus of the unit vector r, it will be 1, so it will give you only force component, and if you find it, its value is equal to mr double dot minus mr theta dot square. Similarly, the transverse part or tangential part, it will be g theta is equal to f dot del r over del theta, and you know that del r over del theta will be equal to r theta unit vector. We know that del r over del theta is equal to r theta unit vector. We have derived it earlier, so we can put it directly, and it will be f dot r unit vector theta. So it comes out to be, when we take the dot product of this, then you again know that the modulus of the unit vector theta, it will be 1, so it comes out to be r f theta. Now when we put the value of this g theta is equal to r f theta in equation 12, then we can find the value of the tangential component of the force. So the tangential component of the force comes out to be finally mr theta double dot plus 2r dot theta dot, and the radial force was equal to mr double dot minus mr theta dot square. These are very important relations, and you have to remember these